Good morning. All right, so this is a combination of 2.1 and 2.2 today. We're going to be doing combining expressions from the book, both addition situation and a subtraction situation. So I'm doing the examples right out of your book today, but I'm not going to answer all the questions. I'm going to just help you guys with the setup for those of you that need it. So first things first. This is out of 2.1, and I got 3 different students for some kind of some kind of walkathon, if you will, some kind of ways to raise money for a cancer or some kind of charity thing. So I got 3 students. Leanne is going to get $10 no matter the amount of kilometers. Gilberto is going to get $2 per kilometer, and Alana is going to get $5 plus 50 cents per kilometer. So I want to write 2 expressions that are equivalent. That I did not finish the sentence. Write 2 expressions that are equivalent that shows the total earned. So we gotta write 3 equations, guys. All right. So if I'm doing that, let's just write this as such. I got my T of L, which is this person right here, Leanne. Well, this person is just gonna get $10. All right. It's pretty basic, pretty simple. Now the other thing is we know there's a number of sponsors, so we'll come to this later. But right now, we're just making the equations. You're getting $10 per sponsor. Okay, now I'll get to this in just a second. I also got T of G, and this person is getting $2 per kilometer. So this is 2, let's call X. You've always got to have your X is your number of km, all right, your number of kilometers. So that's how I'm always organizing my thinking. So there's my equation for Gilberto. And Elena is going to be T of A. We're going to call her $5, a flat fee of $5 per sponsor, plus 50 cents per kilometer. That's why I have those keys. So if I want to write this up, so like one way to get the total amount of money earned between the 3 of them, you're literally just adding these 3 up. So here is one equation I can write. 10 plus 2x plus 5 plus 0.50x. There's one expression. Now, again, you got to start combining your like terms always. So add 10 plus 5. So I got 15 plus 2x plus 0.50x. So plus 2, still waking up, 250x. So again, equivalent expressions, combine your like terms. Now, this is going to be funky because let's say that, I'm just hypothetically saying, let's say that between all of them, they each walked the same amount of distance. Let's say they walked a total of 7 kms. Okay. Now here's where it gets a little funky. All right. We know that Leanne doesn't make a difference. So this is we got to pick apart how to use the equation. All right. If Leanne, Gilberto, and Elena each walked a total of 7 kilometers, Leanne is getting $10 no matter how many kilometers this person walked. But this person has a total of 16 sponsors. So T of L is going to be literally just 10 times 16. So your T of L is 160. Okay. So we got Leanne finished with. Gilberto is $2 per kilometer, 7 different people. So here's how I'm going to manipulate this equation. If I know that, I'm going to take this equation, right, and I'm going to multiply this by 7. Putting parentheses is crucial. You got to know how to use this because obviously after I do my number of kilometers, I take that, multiply that by 7 to find my total. So in this case, we got 7 kilometers. So T of G, it's important you stay organized like this, okay? So T of G is going to be 2 times total of 7 kilometers and times 7. So my T of G is going to be 14 times 7. And my T of G is going to be 7 times 4 is 8. Carry the 2, I got 98. Okay? We got that right there. And then your T of A, you got 11. Sorry, you got 11 sponsors for Elena. Again, we're doing this whole thing times 11. Okay? So we know that we can go in here and I can replace this equation. If I get enough room here. I got T of A. We got 5 plus 0.50 times 7. Okay? Times 11, which is the total number of sponsors. So my T of A is going to be 0.50 times 7 is going to be 3.50. So I got 5 plus 350 times 11. Let me scroll this down a little bit. And your T of A is going to be 850 times 11. And it's too early for me to do this in my head, so let's do this on my calculator. I got 8.5 times 11. So I got 9350. T is 9350. And at the very end, to find the total amount that they walk, you just add all these up. Okay? I will be back in another. I'll be back in another minute with another example. All right, second question. Looks similar to 2.2, but it's not the exact same thing, but the thinking is the same. So here's how this works. You got two equations, and this is a equation scenario for an amusement park that is obviously outdoors, and it's dependent upon the weather for clear, obvious reasons. So you got three different letters. You got a P as your profit, which is how all businesses measure the money they make, but profit is always based on a lot of factors. In this particular situation, the profit's based on the number of visitors. Well, the number of visitors is based on the probability of rain, okay? So I got two questions here, two different scenarios I'm going to walk through with you guys that you'll see similar in today's work. And again, just understand what the letters are and then how to manipulate the equations to which are created equally. Here we go. So the first question, sorry for my handwriting, it says, what profit can be expected with a 35% chance of rain? So in order to do this, I got to use this question first and this question second. Now, before I do all that work, because I'm a big fan of writing, the most equivalent expressions just to make your life easier, why don't I first write an equivalent expression between the two of them? Because if this is V and this number represents V, why don't we just rewrite this equation to be efficient? So my P equals 2.50, and your V is this entire expression, 600 minus 500R minus 500. Well, let's get to work. Let's start doing some distributive property like we just learned in the last investigation. So you got to make sure you use this correctly. So I got 2.5 times 600, and I get 1500. So far I got P equals, remember, this times this and this times this. So I got a thing here of 1500 minus 2.5 times 500, and I get minus 1250 R minus 500. Now remember, I'm a big fan of being efficient with your time, so this way you always combine like terms. This equation is equivalent to this expression, but this can go one step further. Combine my like terms. I got these guys right here. So your profit is going to be 1000 minus 250R. Okay? Now we can quickly answer these questions, and less work means more accuracy. So if I know the chance of rain is 35%, it's basic. P equals 1000 minus 1250 times 0.35. Remember, 0.35. 0.35 times 1250 equals 437. So my profit is 1000 minus 437.50. Subtract that from 1000. Oops. 1000 minus 437.5. So your total profit on a day like this is 562.50. It's a pretty cruddy earning. All right, so now this next question says, what is the probability of rain with a $2,000 profit? Again, using just this guy right here, right? I'm going to rewrite this equation with what letter I know. I know the profit is 2,000. So over here, I'm going to do 2,000 in place of the P is equal to 1,000 minus, what is it, 1250R. 1250R, okay? Subtract 1,000, combine your like terms. All right, so I got 1,000 equals negative 1250R. Okay, well, I wrote this question not knowing that I can already see there's going to be a mistake, because I got a negative number here. So this is going to be the problem. So just follow the math, but this is not going to make sense because I'm going to get a negative answer, okay? Which doesn't, I mean, it was a good mistake, but whatever. Minus 250 equals your rate, your R. So I'm sorry, I made a mistake. I meant to divide there, and I didn't. I did in my head. I subtracted it. My apologies. So the reason I know this answer is wrong is because I'm going to get a negative answer. So I would do 1,000 divided by negative 1250. And I'm getting an answer of negative 80. Negative 0.80 equals R. So there was a mistake there. And the mistake was my situation right here. So give me a minute. For this problem, I did the math right. Everything was fine. It's just the situation, the equation does not support a profit of anything greater than the set amount, because I know this answer is wrong because I cannot have a negative 80%. Remember, negative 0.80 is 80%. Double checking some other math. It's fine. The process is correct, so trust the process. But for this particular situation, this particular amusement park can't have a profit of $2,000 based on the math. But again, we'll go through this in class. I will see you there. All right. But again, trust the process. Everything is dandy. Just remember equivalent expressions, combining like terms, and all that jazz. I will see you guys in class.